Hello, in this video we're going to take a look at Pythagorean Theorem, and this theorem is on page 456 in your workbook. Pythagorean Theorem is for right triangles, and when we have a right triangle we have a relationship between two sides and the hypotenuse, or C. So when we square the legs, and the legs are just the terms for sides A and B, when we square each of those and add them together, then what we get is the hypotenuse squared. So then we're able to solve for the hypotenuse by taking the square root. We could also solve for one of the legs, one of the missing sides, by changing or manipulating the formula around to solve for our unknown. Pythagorean theorem is only for right triangles, so you need to be able to see a right angle in your triangle, and then you'll be able to solve for your hypotenuse. We also need to review the concept that we are dealing with opposites because we're solving an equation. So we're going to need to know that squaring is the opposite of square rooting, so we can use that concept in our equation. So here we have two legs, A and B, with side lengths of 4 and 3. So we use the formula C squared is equal to A squared plus B squared, and it doesn't matter if you have it switched around the other way because it's an equation. So I'm going to write C squared is equal to my A leg, which is 3, and my B leg, which is 4, and now I can start to solve. 3 squared is 9, 4 squared is 16, so the hypotenuse squared is 25. And now in order to solve for C, I need to do the opposite of squaring, which is square rooting. I do that to both sides of the equation, isolating the variable and determining that C is 5, and that's going to be 5 centimeters. So this all came about mathematically a long time ago, where we would have these philosophers sit around and think all day and come up with these theories. And so we can see the theory in action where we have the 9 squares projecting from the leg of 3 centimeters, the 16, and the 25. And so we can see here that we have the theorem in action where we have 16 plus the 9 equals the 25. So for right triangles, using the theorem will always work out. You can always determine that you have legs and a missing hypotenuse by looking directly opposite from the right angle. Your longest side is your hypotenuse, or C. So again, we can create the formula, and we can use substitution to put in our numbers. So we're going to have 6 squared plus 8 squared. So we're going to have 36 plus 64. C squared is equal to 100. And then to get to our variable, we need to take the opposite of squaring, which is our square root. C is equal to 10 meters. So the hypotenuse will always be the longest side, and you can double check your answer when you get it to make sure that the two legs are smaller than your hypotenuse. For the student example on page 458, here we're going to find the missing length, which I can put as a question mark, and we notice that this missing length is not the hypotenuse. The hypotenuse is provided directly opposite of the right angle. So 17 is C, 9 is one of the legs, let's call that A, and then we're solving for the leg B. We can set up, using Pythagorean theorem, C squared is equal to A squared plus B squared, and we can use substitution and solve. So 17 is my C, her hypotenuse. A squared is 9 squared plus B squared. And now I'm going to start to use algebra to be able to isolate the variable. 17 squared is 289. 9 squared is 81 plus B squared. I need to isolate the term where B is, so I can do that through subtraction, canceling on the right, solving over on the left-hand side. That gives us 208 is equal to b squared. And again, I need to do the opposite of squaring, which is square root. The square root of 208 is 14.4. So b, the length of b is 14.4 meters. And again, I'm going to check that. 14.4 and 9 are my legs, and 17 is my hypotenuse alongside. That seems to make sense. I'm satisfied with my answer for B. Word problems are pretty popular with Pythagorean theorem. So here we have a power pole, and it's 10 meters tall. So I'm going to label that right away. And it's to be supported by a 10.5 meter guy wire. This vocabulary is a little bit unusual, but basically a guy wire is just a wire that we're going to attach to the pole and stretch down to the ground to hold it firm. The wire is attached 0.5 meters below the top of the pole. So the wire is attached down here a little bit and then stretched down to the ground. What that does is it creates that triangular shape. How far from the base of the pole will the wire be attached to the ground? So here is the base of the pole to where we're attaching it to the ground. So this is the distance that we don't know. We know the wire is 10.5 meters long, and we know the height of the pole, but the wire is not attached right at the top of the pole. The wire is attached 0.5 meters below. So we're going to have to take the total minus 0.5. The actual height of where we're attaching here is 9.5. So to draw this a little bit better, we're creating a right triangle with a height of 9.5, with a hypotenuse of 10.5, and with a missing leg or side where we are looking for the distance along the ground. So we can use our formula for Pythagorean, knowing that this is a right triangle. C squared is equal to A squared plus B squared. Our hypotenuse is 10.5 squared is equal to 9.5 squared plus B squared. And now we can do our squaring and start to isolate our variable. 10.5 squared is 110.25. 9.5 squared is 90.25 plus my b squared. And just like the question before, we're going to isolate the variable through subtraction of the one side, taking that away on both sides of the equation, leaving us with 20 is equal to b squared. And our final step is to do the opposite of squaring, which is our square root. We'll take the square root of 20 and cancel that out on the b side. And that gives us a distance of 4.5. We're rounding to the tenths place there. So we're going to leave it there, 4.5 for b. And when we look at the triangle, it seems to make sense that we would have 4.5 meters as our length from the base of the pole to where that guy wire attaches on the ground. For a question like this, where you have a grid and you've got a line and you have to determine how long that line is, it may be tempted to try to count boxes and figure it out that way. But that wouldn't be the best strategy because we're dealing with a diagonal line that's cutting through a grid. What would be better is for you to make that line the hypotenuse of a triangle. So from there, because you're dealing with perfectly horizontal and vertical lines, you can determine the legs or the distance over. So we've got 1, 2, 3, 4, 5, 6, 7 units here, and 1, 2, 3 units going vertical. And once you know that, then you can use Pythagorean theorem to figure out the length of your hypotenuse. when you're faced with a question like this one, where you've got a couple of right triangles put together and you're trying to find a missing side x, well, that missing side x is the hypotenuse of this larger triangle, but we also don't know the missing side of that triangle, but we can determine, because that missing side is the hypotenuse of the smaller triangle, it's directly across, and we have legs of 6 and 8. So for this question, you can determine the length of a hypotenuse of the smaller triangle, and then from there you can determine the length of the hypotenuse of the larger triangle, all using Pythagorean theorem. Now you are ready to tackle the exercise for Pythagorean theorem. This begins on page 461 up to page 465. Recommended practice are questions 1 to 4, 7 and 8, NR1 and NR2. Question number 5 and question number 9 are very similar questions. You can try those, but we'll be doing those together on Tuesday. And question number 6, it's not a bad question, but it's a baseball question, and so sometimes visualizing that can be challenging. So you can try that one if you feel like you understand the question well. I hope you found this video helpful.